Hello, we're happy you could join us and welcome today's webinar about how to expose IBM IMS transactions as REST APIs quickly and easily. My name's Martin Bacall. I'm the product evangelist at OpenLegacy. I'm joined by Jorge Millet, a software architect who's going to give us a demo at the end, and Zev Avidan is going to join us for Q&A at the end. In reference to Q&A, please remember you can ask questions at any time. We'll answer them at the end. Also, there's a little arrows in the bottom right of the slide, and you can use that to enlarge the screen to full screen. And now on to the presentation. So what are the goals of mainframe access? Generally, the main goal is digital systems accessing business logic and data. You just need to access that business logic that's inside those legacy systems quickly and easily. We also want to talk about easy and consistent on-demand API creation. What do we mean by that? We want to make sure it's easy and you can consistently do it whenever you need one, and that you can do it on demand easily. If a digital team needs assets and needs access to that, you can do it. But another key thing is clean digital assets. You really want assets that are digital, so the digital team can just take them over and not have to worry about anything else, and having about the mainframe. They don't care, honestly. They just want the data and the logic from it. And you want speed, both at design time, so you can produce these on demand quickly, and at runtime, because when someone clicks a button on an app or something else, they don't expect to have to wait for data to come back. It's also true if you're processing lots and lots of data, you don't want it to be to have it be a lag, be the integration be the lag on that at all. So the next thing is challenges when exposing business logic and data. We like to think of some different challenges. Legacy solutions people are kind of tired of are things like ZOS Connect, where you have to actually install Liberty servers. You might have to use MQ on the mainframe and install it on the mainframe, particularly on the IMS system. And for IMS systems, we want to have to be able to support any version of IMS with it, because you may have multiple different ones, and you want no modification to the IMS system. The other thing you want to think about is conversation or non-conversational transactions. You want to be able to support both of those types of conversations. And generally, you just don't want anything extra on the mainframe and on the IMS system itself. When we think about that, there are lots of different types of entry points you can use: screens, custom applications, the IMS database, third-party applications. All these things are entry points to your system itself. You also want to minimize things like facades. Facades are how you actually have to build a data translation on the mainframe, on the IMS system itself, which then translates the data for you before passing it over to the digital side. You don't want to have those. You don't want to require ESBs as part of the actual integration itself. You might use ESBs for other reasons, but you don't want to require them to make it work. But another thing people usually think about is security. You want to maintain your mainframe security because that's always worked well, but you want to add in some digital security. So when we're thinking about an IMS system, one of the things we really think about is we have a transaction manager and a database manager. And usually we use something like IMS Connect to connect directly to the transaction manager. And this solution I'm talking about here, we're actually using it. You can have a microservice or a serverless function which connects directly to the transaction manager, which then can contact the message queue or do anything else that is needed. The other thing you can also do is have that microservice connect directly using JDBC to things like DB2 databases, and you can also connect directly to the database manager to get after IMS DB. So lots of different ways to connect. The one we're focusing mostly on here is IMS Connect directly to the transaction manager. But all those different ways in this type of solution you need, because you might want to connect in different ways depending upon what you're doing. So in thinking about that whole system, there are 5 different steps you usually go through. The first one, and we're going to cover these in the next few slides, so I'm just going to briefly explain the flow here. The first one is parsing legacy metadata. The second one you want to think about is automatic generation of the SDK. That's the connection logic between those. And then designing the actual API and what's going to work. And then you want to think about automatic test generation, because you want to test everything before you think about deploying it. And you want to automate that process and make it all work. And then you want to think about simplified deployment and runtime. And you want to make it easy to use. You want to make it all work right. So when I think about parsing, There's a few different phases, a few different types of data you might want to parse. The first one is remote procedure calls. These are calls directly in to either a custom application or perhaps an existing third-party application like SAP, FIS, Temenos, things like that. And in doing this, you really need a code fetcher that actually can fetch information from the legacy system, the COBOL code, the XML code, so we can parse it and get the information. And for things like COBOL, we tend to simplify the linkage sections to make it much more easy to parse and understand so we can turn it into digital pieces that you want. When you think about data, you have to have a metadata fetcher, something that gets the SQL, parses the information about it, might be from an IMS database, DB2, or other types, and then figures out the way to make the right calls to it. But another key thing a lot of people don't always think about is their screens. If they have a 3270 screen on an IMS system, you have to have a way to record the screen usage of a scenario, usage scenario of a customer. We use trail files for this. So trail file is a good way to record the information as a user goes through the different screens and figure out their usage pattern. But one of the key things is if you have, let's say, thousands of users using it in slightly different ways, but you only have hundreds maybe of screens, how do you actually do that multiplex? Do you want to have to take thousands of those trail files? No, you actually want to make it reusable somehow. So we can make the recording of the screens reusable because it's code, and then from there you can plug it in. So since I've discussed code a couple times here, I'm going to discuss SDK generation. The SDK is a key part of this. It does data translation of the data itself. And the SDK is a component of the stuff that gets built into a microservice or serverless function. In this case, I'm showing a microservice, also with the API that we're going to cover in a minute. And so you can put a couple different SDKs in here with a couple different access to a couple different databases if you like, or the same database with some data. And this is all source that you get access to, the SDK. It's just Java source code that gets generated and you can modify. So the SDK does the data translation, the orchestration, the integration between those different data sources, and the support for different types of transactions. Here I'm talking about conversational, non-conversational transactions. And what do you get? You get the source, which I mentioned, and you also get consistent generation via templates. Because a lot of people have coding standards themselves. They may have other security standards, ones that we don't support automatically. They're using some other protocol. Well, that's fine. You can build it in a template, have it generated every time. So in security, everything is secure in terms of HTTPS and TSL to make sure we maintain the security of the mainframe itself. But we also have support for things like OAuth 2, OLAP, and LDAP. And those are pretty powerful ones for the design side. We also have Java, which is a strong typing, and we also do data masking. These individual data elements that appear here, that's the only data you see out yourself. And so the whole idea here is that you're now protected from other data getting out through this interface itself, which is an important feature. So when we select inputs and map to outputs, a lot of people think in different ways. They think about contract first, which is using existing Swagger pages. You may already have a Swagger page there in place, and we want to connect to it. So we support that very easily. You can apply the Swagger, and then from there you map that to the data that's coming in from the SDK and figure out where you go. Or we can build your own Swagger page and make it a lot easier and then generate the API from that. It's your choice, whether it's one we create or one that already exists. So when we think about automating the test generation, we think about a few different things. We think about JUnit Tests, which is a common Java testing mechanism. Well, we generate the JUnit tests for you, and that allows for good unit testing, but also regression testing. But we make it easier because we add a JSON-based testing framework where you can have default input-output parameters and no Java knowledge required, because sometimes your testers don't know Java. And so we make it a lot easier for them to just plug in tests and make it all work. But we also generate the Swagger for you. Swagger allows you to test the input and output of the APIs, which gets at sort of your integration testing, because it tests the whole integrated system for what should come, what gets put in and what comes out. And also it helps with deployment testing, because now you know your API will work as expected. So then afterwards, we think about the step 5, which is simplified deployment and runtime. The whole idea with microservices architecture is you can deploy anywhere with a microservices architecture, whether on the cloud, whether on-prem, any of these types of places. And you can also bring legacy data to the cloud because you have Docker bindings and you have a container built in. It just makes it much easier, much more simplified process. But the other thing we want to think about at deployment is the runtime. We have direct connections to speed that access. You have a direct connection to the legacy system to retrieve the data. Now, if you want to put that into a queue, say Kafka for streaming or RabbitMQ or anything like that, that's great. But that's on the other side now, in the digital side, they can decide how they want to deal with that data if they want to queue it up. We make the connection and the integration really fast. So now I'm gonna move over to Jorge for a demo.
Thanks so much, Marty. You can hear me well, right?
Yes, I can hear you fine. I can see your screen.
And you can see my screen as well, right? Okay, perfect.
Yep.
Well, thank you very much, Marty. What I'm going to do is run a demo from scratch. Everything that I'm going to create is something absolutely new. We don't have nothing prepared before. So you can see the entire process. And this is a very visual section of the webcast. So please help me by enlarging a little bit your image. On the bottom right, you will have these arrows. So please enlarge. And let me start by explaining you what I'm going to do. Basically, as Marty mentioned, we're going to use our IDE based in order to create an SDK and then an API. The SDK, first I'm going to generate the structure, defining which connector and what connection properties I'm going to use. Then I'm going to create the metadata that corresponds to an IMS object. In this case, I'm going to use some information related to a phone book. And then I'm going to create an API that is going to consume that SDK and is going to expose that information in a Swagger specification mode. Okay. So let me actually start by showing you what do we have on the mainframe. This is a very simple environment of an IMS. Okay, and inside of the IMS, I have this format. I have this format where that is showing my information in the AMS, and here in the AMS, I'm going to just show you some information that I have for this specific person. Okay, this is what we have inside of the mainframe, and this is what we're going to be hitting from the IDE. Okay, as I click end, I just can close this, and then I'm going to open for you the IDE. This is our environment, and as I mentioned, we have tools that are going to help us building the APIs. The idea is that the developers, they only need to run wizards. Each one of the wizards is already defined to run each one of the steps and to make it as simple as possible and as easy as possible and also as powerful as possible, because every time you generate the SDK or the API, you keep the code. You can see the code and you can even change the code at that level. So right now I'm going to run the generation of the SDK. So let's call this the demo IMS SDK. And I just need to pick and choose the connector. As I mentioned, in this case, I'm going to run the IMS. We have some options here. From here, I could actually use templates. Templates are very powerful in order to customize or standardize the way I want the SDKs or the APIs to be generated. So I can work with some things like increase security or change the security standards, do some formattings or coding standards. And I can even change nomenclature or naming conventions here. Some advanced options here, I can play with caching. Caching is going to help us in the long run to basically reduce a little bit the MIPS consumed. So I'm going to click next here in order to generate the structure of my SDK. And here is very important. From here, I'm going to start defining basically some parameters that are going to help me to take control of what's going on inside of the mainframe and reduce risk as well. Okay. One is my data store. So I'm connecting here with the Rack F. So Rack F is going to take control of my security. So you can actually create profiles from here in order to make sure that you're keeping the control of what is going on. And some advanced options related to basically IMS is the possibility to change the message exit or even the commit mode. So I'm going to use this send and commit in this case. And as I click finish, this is going to generate the structure of my SDK. And going back to my diagram, you will see this is what I just did. I'm giving the connection properties to enter to the IMS. I could be able to use and create as many SDKs as I need, enter into the mainframe several possible ways, as mentioned by Mario already, DB2 or Kix transactions or MQs or BSON files, and many other legacy systems or legacy assets that I can get into. So from here, what I'm going to do is create the metadata that corresponds to the copybook that is defining the IMS. Okay, so let me bring this for you and open for you one of the copybooks. This is the information that we have on those copybooks. So I'm going to go back to the IDE. Here I'm going to open the SDK that I just created. I'm just going to fine-tune some stuff here. I'm going to do this parameter as true because I want to generate the copy as entity. So let me save that one. And I'm also going to go inside of the resources and make sure that in the YAML file, I have the offset as 0 in order for the data is properly managed in and out. So just click offset and put this at 0. And then I say that. And from here, I'm actually ready to bring my copybooks. Let me go bring my in and out copybooks. I just moved that into the resources area. There's two options here. I could actually be pointing to the copybooks inside of the mainframe in order of, in the interest of time, I'm copying this here to make it faster and easier. And I just brought, for some reason, only the phone out. Sorry, let me bring the phone in. Okay. Now I just right-click on any of the copybooks, and I ask this to generate the model. So I'm running right now the wizard that is going to help me create the metadata for that specific phone book information. I could be able to generate the JUnit Tests. So since this is a standard IDE, you can connect this to any repository standards that you have. If it is GitHub, you can connect it to GitHub and generate the JUnits, and this is going to be integrated to your CI/CD immediately. Okay. So as I click OK, this is going to generate my SDK. And it's very important here to show you the information that we're getting immediately and automatically. We have here general information about the SDK, and you can see that we already have identified the structures that we have. On copybooks, we can deal with structures, substructures, variable fields, and fillers, that kind of difficult information to deal with, and we have automated all that. So the generation of the code is here. You can see that inside of the structure of my SDK, I can access also the detail of the input and the output. Here's the source code that is actually controlling that information. And this has been already converted to Java understandable, the data. Okay, so that's the SDK. Then I'm going to build the API for you. What I need to do is just go here and run the wizard to generation of the API. I'm going to call this demo IMS API. And again, I could be able to generate a microservice from here, any flavor you want to use, in this case, Docker, PCF, or OpenShift. Also templating back again, if you want to deploy your APIs in any specific mode, let's say you want to deal with pre-existing API gateways, we can prepare the APIs to automatically deploy to that standard, or message queue manager or services meshes. We can do that here in order to make sure that every API that you produce is going to go out into that standard. And also the security, you can template the security here. In the advanced options, we already mentioned about the contract first projects, and I already mentioned about the enable caching. So that is also very powerful because having caching at both levels, the SDK and the API, is going to help you even more to get control on what is going on in your information. So I'm just going to produce, in this case, a standard API. I'm going to click Next. I'm going to use the SDK that I generated for you, consume it as my input, my dependency, and as I click Finish, this is going to create the entire structure of my API. And the next thing is to generate the contract. Usually generating contracts takes days or takes a lot of time because it needs a lot of communication between the developers and the legacy areas. In this case, since we already made the conversion, it's very easy for us. The only thing I need to do is just right-click on the API that I just created and tell I want to generate an API from the SDK. I just gotta put the name to my API. I'm not gonna play right now with parallel execution or pooling or nothing like that. What I'm gonna do is just define the inputs and the outputs. The input is gonna be the command and the last name as we saw in this green screen that I showed you. Okay, and the output is going to be everything. So as I click OK, this is the generation of my contract. My contract is ready. Okay, and I have these methods. I can add new methods. I can see the information that is coming in and out, the backends that I'm working with, and here is the mappings. I can actually change the names of anything that I want here, the mapping expression. But the most important thing is that I have control of the interface, I have control of the implementation, and I also have control of what's going on outside on the controller. So from here, the only thing I'm going to do is to show you this API running. I'm going to run it locally. Let me make sure that I have. Yep. It's going to consume the SDK. So deployment methods, right now I'm just running the API in a software standard mode. So this is going to run locally and take control of my port 8080, and I'm going to show you that running here. But another option is I could generate the jar file, and that jar file could be deployed into any runtime that you may have already. And as I mentioned, it could be templated, and so that jar file or microservice could be ready to be executable in any environment that you want. So this has to control already of my environment, local host port 8080. Let me go to Swagger. And by default, we have OAuth 2 security that can be changed or improved. If you want to use other token standards like JWT, you can use that as well. I'm going to post my API, try it, and I'm going to, like if I was inside of the green screen, I'm going to put the inputs as I did there. And as I'm going to execute this, and my API, sorry, my IP address is not okay. Let me change the IP address because I can fix that right here. Okay, I don't know if you want to answer questions. Meanwhile, Marty, I'm going to change the IP address because I made a mistake here on the IP address. So let me go to the application YAML file.
Okay.
And,
okay. While he fixes that,
I missed one dot here.
Yep.
Okay.
One comment from the audience was actually mentioning that. So, thank you very much. This is a very much a live demo. He's doing this on the fly, so you're actually seeing how quick you can actually create these things as you go. So that's pretty amazing that you're seeing that. But I'll answer one of the questions that came in, and then you tell me when you want to get back to it. Can OpenLegacy replace ZOS Connect and other MQ tools to expose the existing IMS application? If so, do I need resources with IMS skills to do this? The answer to that is yes, it can replace those things, and you don't need IMS skills to do this. So other than knowing which files we have to, the COBOL files or whatever files we have to get to access for the parsing, there's no legacy skills needed in terms of the COBOL itself, because we parse it and we give you back that data, and then we can actually show you the inputs and outputs you can map to inside the tool. There's no specific legacy skills needed once you find the right files and do all the different elements that you need. Another question that came in is, what's the difference between a trail file and screen scraping? That's a very good question. The biggest difference is that trail files, you only get the data, which comes back out from the screens themselves, which is helpful in many cases and can allow you to do a lot of things, but it doesn't allow you to modify what you're actually building and build some usage scenarios that are different based upon it. Trail files actually give you all the information, which includes the data and the fields, and we actually generate then source code in Java that then is very easy to modify. And we have a large insurance company in the U.S. which actually moved from screen scraping to trail files because they wanted reusable scenarios where they could build up a library of them, and then whenever someone asked for a specific use case, they could easily build it quickly rather than having to generate a whole new set of files and have to generate everything by watching the user. They could do it much more quickly and much more easily. So those are two questions, and now we'll move back to Jorge to finish up the demo.
Thank you very much, Marty. So yes, I had an error on the IP address. That's what happens when you're doing live demos. But I just changed that and relaunched my API, and you can see I displayed the information for Jones. First time it runs is a cold call, so usually it takes a little bit longer. In this case, was about 300 milliseconds. But for the second time, not even having caching, you can see that it's taking less than 100 milliseconds. So the speed is also a very important thing that we can improve. And very important also to mention, we're not installing anything in the mainframe. We're using what you already have, okay? And for the case of IMS. Going back to you, Marty.
Okay, thank you very much. I'm going to switch back over. Thank you for the demo, and I'm glad it all worked out in the end. That's what happens with live demos. So another question that came in is, you mentioned serverless functions, but what are the differences between those and microservices? And serverless functions, which Amazon uses the term Lambda functions, other vendors say serverless functions, are literally functions that then get deployed directly, and you hook them up to triggers in a serverless cloud. So rather than building the API for you, you build the API, if you choose to use an API, inside the cloud vendor itself. So in that case, we generate just the SDK, and we actually generate it in JavaScript, Node.js code rather than Java code. The big reason why we do it that way is because Java can have a long load time, and these in serverless, the applications are always loading and unloading onto the server itself. It's not really serverless in the sense that there is a server. And so because of that, Node.js and scripting languages are just a lot faster to load that initial time. So in that case, we actually regenerate it as JavaScript, and that's not going to work if you have an ESB type product or something else embedded in there, because those are all written in Java, and you have to call the whole Java library, and everything else has to load, which takes more time. And so we cut down drastically the amount of time it took to respond to these things, and that also is processor time, which is what you get charged on by these vendors when you're doing serverless. So if you're choosing to do serverless, you really need a function, and you really generally don't want to have it in Java. There are workarounds for Java, but that means pulling out the library, pulling out many other things, and that becomes a hard way to handle it and a hard life to lead. Any comments on any of those questions, Jorge?
Yeah, I think it's very important to mention the way we manage the tray files, because what we're doing is do it reusable. For the screen scraping, in case you change anything, whatever in any of the screens, you need to rebuild the entire process. With the trail files, you can only rebuild the part that you need, which is the new, let's say you're adding a field, you just add that field and rebuild everything. Or if you're taking fields off, it's very easy, you don't need to change anything, so that's make it easier for the user and the developers as well.
Sounds great. Yeah, it's very much reusable. That's the big reason why that company I mentioned earlier is actually went to us. They wanted reusable ones versus things that they had to build every single time by scraping a screen and building a new scenario, which to them just wasn't was a no-go. It wasn't scaling for them. Another question is how can this solution help if we want to do a phased migration? We can help a lot with phase migrations. Everything we showed here was microservices. So you can actually expose things quickly as a microservice, and then later on, when you're ready to actually move things over, let's say to the cloud, some components of your system, you now have it split up in a very reasonable fashion, based upon the APIs people are using. And from there, you then can just reroute those microservices to point directly at the new services that are in the cloud. So generally, everyone always talks about, I'm going to replace the legacy system. Now, whether or not you do that, you might choose to do just some components replaced. There's many different facets you go through, but most people talk to 3 to 5 year process in the best case to do that. And with microservice type solution, that's a very important thing to even think about. Any other comments there, Jorge?
Yeah, well, you mentioned microservices, and I think it's very important to make sure that everyone understands that the way we produce the microservices is by putting the API and the SDK inside. And microservices is the part of the, microservices has basically three parts. The first one is the load. The second one is the data. And the third one is the logic to control everything, or the payload. And so basically the data, in the case of the microservices that we build, is real data, real-time data. We are not needing to create data lakes or temporary information moving back and forth. So that is going to reduce also the risk of controlling the information for the end user. So our microservices are not exactly the regular microservices as known in the market,
Yeah, that's a great point. I mean, our microservices are used to connect to the legacy system and get the data from there. You can do some caching to try to speed things up if there are things you're regularly attaching to, but in general, they're used as a connection point, and also to do some data translation between multiple different elements of data inside there. And then from there, the microservice has the SDK in the API, which is why I moved back to the slide. And so we actually have those things as part of the microservice. All right, well, thank you very much. I'd like to thank everyone for this presentation. I think we're going to close it out now. There will be a recording available from the same link you got here. Please feel free to pass that on to anyone else, and we'll take it from there.